Hello everyone. Today I'm going to be talking with you about the area of a circle, and it's just not the formula itself, because we already know that the area is equal to pi r squared, but we're going to take a look at the derivation of this entire formula. How do we get to that point where we can say pi r squared is exactly the area of a circle? And that's the point of this video that I'm going to be going over with you today. So first, we have an integrand here in this integral. We're going to be using calculus here and several different types of substitutions and relationships in order to integrate this entire thing and to come up with a general expression. The integrand here, which is f of x, equals r squared minus x squared, and that's square rooted. Of course, f of x equals y, so by association, that's also equal to y. Well, what exactly does that look like? Well, we have x here on this axis here in this dimension, and we have y here on this axis in this dimension. And so the graph of r squared minus x squared, saying that this is r, which is a particular value of x, and this is negative r, which is another particular value of x, looks like this. It's a half moon, I guess you could say. And so if we want to get the area of the whole entire circle itself, what we're going to do is we're going to double that. And we can do that only because it's symmetrical. The bottom half of this circle would look the same as the top half, so we can double that. And that's where the 2 comes from, because this area here is what this will cover. All of this here is what this will cover. And then we double it because it's symmetrical, and then we get the whole entire circle itself. So that's what we're going to go over today. And we're going to start with a trigonometric substitution. And that trigonometric substitution is going to be that x equals r sine of u. Okay, we're going to use that substitution. So if we differentiate x and we get dx, it's going to be r cosine of u du, because we differentiated, so we're going to have a du, kind of like a byproduct. So we're going to substitute that and use that in our integrand. But before we go ahead and we do that, let's change our limits of integration. And so for our upper limit, when x equals what? R, okay? We want to find out what is u. So x over r, we're going to use basic algebra here. X over r equals what? Sine of u. X over r, arcsine of x over r equals u. So the arcsine of what is r? What is x at the upper limit? R. R over r equals u, which equals the arcsine of 1, which equals u. Well, what's the arcsine of 1? Well, generally speaking, that's at a degree measurement of pi over 2. So at pi over 2, our sine function is equal to 1, to unity, figuring that our radius here is equal to 1. because it's going to be y over r, which is y over 1, which equals pi over 2. And so for the upper limit, we're going to have pi over 2. What about the lower limit? We're going to evaluate when x equals negative r. Get our lower limit. So the arc sine of negative r over r is going to equal u, which equals our lower limit. And that's going to be arc sine of negative 1. So negative r over r is negative 1. And for negative 1, let's look at a graph here again. If we're at negative 1, what's the measurement? Negative pi over 2. So we're going to have negative pi over 2 here for the lower limit. So we're going to rewrite this whole entire relationship using our substitution. And we're going to have the area equals 2 pi over 2 negative pi over 2, okay? Because that's what we were talking about. R squared minus x squared. Well, what is x? X is r sine u. So we're going to have r squared minus r sine of u. That's going to be squared. That's within the confines of a square root. And dx, we're going to have r cosine u du. And that's going to be our new expression. We're going to stay with that. We're going to stick with that for a while until, if need be, we need to switch over to something else. And so we're going to go ahead through that, and we're going to simplify. And what do we have here? We have r squared. This is squared, right? So it's going to be r squared minus sine squared of u. That's all under a square root. The argument here is u du. So now we have that expression. We have that expression, and then what we're going to do is we're going to factor next. So now the area equals pi over 2, negative pi over 2. And we're going to factor out, and we have r squared times 1 minus sine squared of u. Of course, that's all going to be under a radical there. And we're going to have r cosine u du, right? I forgot to include my 2 there, so I'm going to put it here. And so this area here is going to be equal to 2 pi over 2 negative pi over 2. And we're going to take this r squared out, and it's going to be r. 1 minus sine square u under a square root r cosine u du. This multiplied by that is going to be r squared, right? So now our expression is going to be r squared 1 minus sine squared u under the radical cosine u du. What we must take note of here, and this is all a part of it, we're going to take note of that the fact that 1 equals sine squared x plus cosine squared x. X is just the argument. So 1 minus sine squared x equals cosine squared x. We're gonna leverage that, and we're gonna use that to our advantage, and we're gonna put that in here. That's not a substitution, that's just a relationship. So our area now is going to be equal to 2 times, of course, our upper and our lower limit are squared, and we have cosine squared u under that, and we have cosine of u here and du there. Now what can we do? Well, of course, we can bring that on out, and we have this expression, we have r squared, we have cosine of u, cosine of u du. And quickly you can recognize that the area in a simplified form is equal to r squared, and then we have cosine squared of u du. Now, what we're going to do is going to bring that r squared out, because r squared is just, for the most part, it's a constant. So we can bring it out in the front. So area is now equal to 2 r squared pi over 2 negative pi over 2 is our limits. And cosine squared u, what we're going to use, we're going to use a trigonometric relationship here. Anytime we have cosine squared of x, we can make that equal to half of 1 plus cosine 2 times what? The argument x. And we're going to use, this relationship. It's not a substitution, it's just simply a relationship. And we're going to use that relationship in here. And so now we're going to call that, we can call it 1 over 2, that's the double angle formula, 1 plus cosine of 2u du. We're going to have it like that. So next, we're going to bring this half out in front. 2 over 2 is 1. So now we have just plain old r squared. We have 1 plus cosine 2u du. Well, we're getting closer here. Now, we're going to take notice of the fact that cosine 2u, we can make a substitution for that. But first, let's divide these two up. And let's take note of the fact of that, areas or integrals can be superimposed on each other in terms of addition. That's a preliminary to superposition. So what we're going to do is we're going to say, I'm going to make an expression here. Okay, so that looks right. What we've done is what? We've expanded the expression and now we have two parts to it. So in this expression itself, we have r squared, and then what? Du, we have u raised to the first over 1, which is just simply u, and it's evaluated at the limits of pi over 2 and negative pi over 2, plus whatever else we have over here. Now you can progress through the problem at any rate that you want to, but I'd rather, it's just preference, I'd rather just go ahead and figure out what we have here first, since that's already basically at a point where it's easier to evaluate. And so we have r squared, right? It's going to be minus, or multiplied by pi over 2 minus negative pi over 2. And we have our integrand, our integral over here. And so this is going to be a plus, it's going to be a positive, and pi over 2 plus pi over 2 is just simply pi. And that's the relationship. So we're going to make some more room here again. And so we're going to take notice of here is that automatically we can see, oh, we got pi r squared. Let's quit. No, you can't quit, because this is a proof. You have to go through every portion of it in order to make sure that you're absolutely correct in your derivation. So we're going to keep going on and working it. And sure, we have pi times r squared here. But what about this other portion here? Well, we're going to take notice of the fact that for our double angle formula here, we're going to substitute something, or actually we're going to substitute that 2u equals alpha. Okay, 2u equals alpha. This is substitution, and so 2 du equals d alpha, right? Because we differentiated u, and we have a differentiation of alpha, and the 2 is the coefficient that comes out in the front because we just differentiated alpha. Alpha was to the first power, now it's to the 0 power, which is 1, and so we have this. situation here? Well, if we're going to make the substitution, we don't have a 2 du. So what do? Du equals d alpha over 2. We're going to have that situation. Also, what we're going to do is we need to create another upper limit since we're doing substitution. So our upper limit, where u equals pi over 2, okay? So 2u equals pi. We're going to have pi over 2 when u equals that. And we're going to have 2 here. So 2 times u equals alpha. 2 times u equals alpha, which will be equivalent to pi. For our lower limit, we're going to have negative pi over 2. So negative pi over 2 times this 2 here that we have is going to equal negative pi. And that's going to be our lower limit. So lower limit here, upper limit here. And so we'll go ahead and we'll write that here, that our area equals pi r squared plus r squared. And what did we say before? Pi. We have negative pi. Cosine of what? Alpha. D alpha. D alpha was what? Over 2, right? I have d alpha over 2 because, again, we'll write the relationship. We made alpha equal to 2u. So d alpha equals 2 du, and d alpha over 2 equals du, right? So d alpha over 2 equals du, and that's put in that place. So next, we have pi times r squared plus r squared, and then we're going to take that r squared, bring out that half, and put r squared over half. We have pi, negative pi, cosine of alpha, d alpha. Now, it's gotten a lot simpler over here on this side. And now the area is equal to r squared plus r squared over 2. And if we integrate just a simple cosine, which is what we reduce this to, we integrate a simple cosine, we're going to get the sine of our argument between our limits, which is pi, and negative pi. We'll make some more room here. And sine of pi is what we're going to evaluate this at, minus sine of negative pi. Evaluate it there. Sine of pi is what? Well, look at the graph again. If I go all the way up to pi, which is here, y to r, this is a different r, call it, give it a subscript, r of 1 if you need to, and we're talking about the unit circle, so that'll be 1, y over 1. Well, what is the displacement of y? It's 0, because it's lying right on the x-axis. So, what does that mean? 0 over 1 equals 0, right? So sine of pi is equal to 0. What about the other way around? What if I go negative pi? Well, negative pi is a clockwise direction. This was counterclockwise, which is a positive, rotation orientation. If I go negative pi, which is a negative orientation, and I wind up at the same spot, what's y over 1? Because we're dealing with a unit circle here again. Well, y over 1 equals 0 over 1, which equals just plain 0. So we have the sine of negative pi equals 0. So we're going to subtract 0 from 0. And if you have 0 from 0, that's going to leave you with 0, of course. So we have pi r squared plus r squared over 2 times 0. And so that means that we have area equals pi r squared. And so, with that being said, this is our final answer of why we have the area of the circle. And we did quite a few different substitutions and techniques here. We did trigonometric substitution. We took note of some trigonometry identities and relationships here. And by knowing all of that and being able to create that sort of relation, we can get down to the point where we know that the area is pi times the radius squared. So hopefully this video was helpful for you. Thank you for watching and have a nice day.